So my name is Tim Ernest. I'm the Assistant Pavement Materials Engineer for Oregon DOT. John is more involved in the higher level decisions when it comes to our preventive maintenance treatments, and I'm more involved in the detail side. So I'll go out, evaluate projects. I'm even involved on the design side, and then also the specification writing for some of our newer treatments. And so John had a pretty good presentation talking about the higher level stuff about Oregon. I was going to kind of follow the theme of this year's state agency reports, talk about some of our success stories with our preventive maintenance treatments, and then also maybe some innovations as well. So far we've had two bigger microservicing projects on our main roads. Our first one is almost exactly 4 years old to the day. We had that on Interstate I-84 on the eastern part of Oregon there. This section was a black and white section, so most of our central and eastern Oregon interstate is, so we have our concrete truck lanes and then we have our asphalt passing lanes. I don't recall the pavement condition of that at the time. I knew that it had been paved within 10 years. There was very little cracking because it was in the A lane or passing lane. So I didn't see a lot of that truck loading. There's about 9 lane miles that we put down, and that was kind of our test section to kind of get into microservicing on a larger scale. And that project went very well for us. I visit that project every year, even this year. It almost looks exactly like the pictures still show there. Very dark, very little distresses. In fact, the only distress that you could really see is on the skip stripe there. Our snow plows kind of overlap by a few inches, and you can see a little bit of kind of scuffing of that surface, but the material itself has held up really well. 2 years after that, 2020, we had another project very close to Salem on Oregon Route 22. This one had various construction histories, various pavement condition ratings, but overall that was a pretty successful project for us outside of some very isolated areas that they had problems with the microservicing. That was about 13 lane miles. Some of the localized issues I noticed when I was out there was mostly had to do with the mix. It was setting up really fast on them, so they didn't have a lot of time to kind of work with it. They brought in, added some aluminum sulfate to the mix to kind of help retard that set. And I think that sulfate helped to kind of deteriorate some of the aggregate that we had in that mix. And so there are some localized areas where you'll see some raveling in the outside wheel paths, particularly in our eastbound section. But overall, I think that was still a successful project. But those localized issues definitely kind of, I think, gave it a little bit of a black eye, especially being that close to the capital there. Regardless, we do have a big microservicing project that's coming up pretty soon. It should be out to bid later this year. Again, that's going to be on I-84 in the eastern half of the state. And we have about 57 lane miles going down there. So again, that's going to be in a black and white section. It's in relatively good condition, so we're hoping to get some good bids on that one. So here's kind of the cost that we had on that. So the first project was about 67,000 square yards. The cost is about $549 per square yard, and that's total cost. Our Salem project was 219,000 square yards. We paid about the same. I think material costs that equals out to about $350 a square yard. We did have one big, well, it wasn't big. It was one asphalt rubber chip seal project. There was actually 2 sections of 2 different highways combined. The first section was in Ontario, which is basically on the Idaho border there, 1.95 centerline miles. This section was paved in 2003 with a really stiff, dry mix, and so there was a lot of top-down cracking. It was actually rated 2 points above a poor condition whenever we put the chip seal down. So 41% fatigue cracking, you can see in the upper picture there. Our maintenance crews did come in, do a really good job of crack sealing that beforehand. And the picture below that is the same section, same location, right after the chip seal had went down. This section is still performing really well. It does look a little kind of flushy in the wheel paths in certain locations, But once you actually get out and inspect the road, it's not flushing. It's just a little bit darker where the truck traffic has hit it. The other part of that section was kind of adjacent on US Route 20, and a town called Vail is in the couplet area. Really, it was about 3/4 of centerline miles, overall 3.34 lane miles. Again, this section was last paved in 2003, and depending on which section of the couplet you're in, we had very different condition ratings there. One was in poor condition, the westbound, and that's because we did have another major route that kind of came into US 20 at that location and took the westbound route. So we had significantly more truck traffic in that direction. This section has held up well too. We did have a couple issues on this one, on that westbound side with the 43% fatigue cracking. Our maintenance crews came in, they did crack seal. They did crack seal some alligatored areas also. And we kind of learned that was kind of a mistake. So coming in, they put the material down, placing it at 300 plus degrees. That asphalt rubber bonded to that crack seal material. So that next summer we had a real hot spell, had a lot of trucks coming through there. It started to actually tear the mat in those locations where they put a lot of crack seal material down. And so of course everybody was kind of screaming, at least on the maintenance side. And then as John had mentioned earlier, with the higher cost of it being on the east side of the state and our producers bringing the material from basically Vancouver on the west side or upper northwest side of the state. Yeah, it really didn't, from a agency perspective, didn't look well, but the material has performed well for us. And I think in the right application, we might use it again. I had mentioned this last year at our virtual meeting, but we did have a project where we implemented a performance/warranty specification for our chip seals. So a little bit of background, Iowa State came in 2014, 2015 with a research project with us, working on ways to improve our chip seal performance in Oregon. At the time, we had maybe 2 chip seals that had went kind of sour on us, but overall 98, 99% of our chip seals looked great, but those 2 just kind of like stood out and gave the program a black eye, and so that actually helped us get funding for that research project. So basically they compared our current method-based specification to a performance specification that is being used quite extensively in New Zealand. If anybody's interested, that's ODOT report SPR 777, and you can email me afterwards, and I can always forward you guys that information as well. After that report came out, we did get a state grant to help implement those research findings, so implement that specification. So basically what it is, a contractor responsible for setting their application rates. They're responsible for placing and finishing that chip seal. There is a 1-year warranty period. So they're responsible for repairing any identified failures, so bleeding or aggregate loss in that 1-year period. And then at the end of that, we do another inspection, and they have to meet or exceed a performance measurement. So for this one, it's going to be macro texture is what we selected. So continue on, the inspector role becomes more than an observer, so we're no longer directing the rates or the methods of the contractor compared to what we previously did. Inspectors are more focused on the materials, the equipment, construction quality control. We have 2 inspections. One is scheduled within 2 weeks after the chip seal has been placed to make sure that everything's to our satisfaction. There's no areas where we have flushing or that aggregate loss. And then once we're satisfied, we'll notify the contractor that that 1-year warranty period begins. So in that 1-year warranty period, we notify them of any repairs needed. They come out within 14 days with a plan to get those fixed. And then after 1 year, we have a post-construction inspection where we basically go over the same project again. And then I will come out and do our performance measurement. So for every lane mile, we're doing some of these texture measurements. So part of the specifications require the contractor to go through a chip seal design method to kind of come up with their design rates or their application rates. The method that was used in our research project and the one that we selected was the McLeod method. Because it is a well-established chip seal design method, it does take into account and tries to mitigate your typical failure criteria, so your flushing, your bleeding, and your chip loss. It also helps to calculate your recommended application rates based upon your various aggregate properties, and then also some of your traffic and pavement surface conditions. So inputs includes your aggregates for average least dimension, flakiness index, which basically is your flat and elongated. That's a different way of doing that. Calculate your voids in your loose aggregate, bulk specific gravity, absorption. It takes those into account as far as the emulsion application rate. Traffic inputs, so we look at our ADTs. It gives us a traffic factor that the McLeod method uses. Traffic volume and speed gives us a whip-off factor for waste, because there's always something that we're sweeping off into the shoulder. And then it also looks at the surface inputs of your existing pavement conditions. So how porous is that surface? How oxidized is it? Is it a 3/8 mix, or is it a 3/4 inch mix? Was it paved 15 years ago, or was it paved 8 years ago? That sort of thing. And those can be pretty subjective, obviously. So performance measurement is your macro texture. So when we look at that, we're looking at the whole aggregate shape as a function of the chip seal itself instead of the micro texture, which is the surface of the aggregate. Again, for our specification, we do 5 tests at one randomly selected location per lane mile. We'll then average those and then plug those into an equation, which helps to, which gives us an expected chip seal life. So, or the texture measurement, just your sand patching method. So you pour a known volume of sand, you spread in a circular patch, you measure your diameter in 2 different directions, and then you can plug it in the equation and get your surface texture. So this is important because it helps to transfer our risk that we take with our chip seals by setting those rates, and gives it on to the contractor. So that if there's any issues, we can, it helps us in a claim situation. It helps to improve the cost effectiveness of chip seals by increasing our performance. And it also provides us with a rational method for evaluating our application rates for the contractors. And ideally, this will help to encourage innovation in the materials and the construction, once we open it up a little bit more. So where we are, we've had the specification approved. That was a really long process. We had to go not only with our specification engineer, but also our Department of Justice to get approved. We had 1 pilot project in the book so far, and realistically, we didn't see any increase in our prices for our chip seals. So we were paid about $32,000 a lane mile for that project, which equated about $415 per square yard. So potentially where we want to be, we want more projects. We do have 1 coming up, maintenance contract that should be going out pretty soon for next year. Obviously, being able to use that more and more is where we want to be. Potentially contractor certification. So if there's some, NCPP or the AASHTO chip seal certification. And then also to encourage that innovation in materials and technologies, maybe look at doing an alternative bid process rather than just doing our lowest cost typical method. Continue on with the innovation. Right now, we do have a current research program going with Oregon State University, looking at our chip seal qualities, not only the materials that we use in our states, from our aggregate sources to also our emulsions, but also construction methods. And if you want more details on that, I can forward you some presentations that they provided for us. That research project just kicked off. And one thing that I've kind of added into that project, and you've heard me ask about it here, is the use of RAP in those treatments. And so we're looking at implementing RAP into, at the very least, our chip seals on our maintenance side, and then potentially as we start using more and more micros or slurries, using that material in there as well. So that's all I had. Thank you, guys. Do we have any questions?
Good presentation. This is Gary Hicks from the California Pavement Preservation Center. I think you answered my first question about what method you were using, and that was McLeod, but AASHTO has a new design. The TSP2 program has developed design practices and materials specifications and construction guides for chip seals, slurries, microsurfacings, and a whole lot. I don't know if you all are aware of that, but they are available. And the design procedure for chip seals in the AASHTO guide is not the McLeod, but it's the one based on Texas practice.
Is that
So-
the Kirby method?
Yeah, it's based on that. So I just want to make one aware, if they are not aware, that those design practices, material specs for all of preservation treatments, including construction guides for some, there's still some that are being developed, are available.
Okay.
And you can find those on the NCPP website. What is it, Bozid, is the ETF? Or are you here? I think it's, go on the NCPP website and look under ETF, and all of those design practices, best practices, and construction guides are on that website. Okay?
Yeah, thank you. Yeah, we were aware that they were available, and it is something that we're looking into. Obviously, like I said, the McLeod was something that we kind of worked with Iowa State on during that research, and that's what we used. But yeah, thank you.
Charlie from Nevada. I have a question on your black and white pavement. So since your travel lane is concrete, passing lane is asphalt, how you identify that in your PMS system? Is there a special way to do that? And during your distress survey, do you measure both lane or just the outside lane?
I'll answer that. It's completely windshield. We're paying our data collection contractor to collect that concrete lane. And I thought about, should I pay that data collection contractor to make another pass on that fast lane and those sections? And I went, I don't think I need to. I can figure this out via windshield. But yeah, if I wanted to be scientific about it, I'd go collect that information. So windshield plus time, and also our districts were kind of hitting us in the head going, these fast lanes, they're getting old and, and nothing's happening on them, and like, oh yeah, that's right.
Quick question, just out of curiosity, when you were talking about your chip seal spec, there was something that caught my eye there about repair failure being part of the warranty.
Correct.
How's that language look like in your specification? Number one, and number two, when you wrote it, did you have feedback from contractors to let them know about that particular part, because it is part of the warranty?
Part of the language, I could actually send that to you, Antonio, if you like, so you can actually take a look at it. But yeah, the contractors were actually heavily involved in the research process itself. So for the year or two that we were with Iowa State, we had a number of conferences, meetings, where we invited all of the contractors in the state that did chip seal work for us, so that they can be involved not only in the conversation, but also the development of the early specification. Thank you, guys.
Thanks, Tim.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.